Hi friends, here we are given in some base n system. We don't know what is the 10. With 3, 5, 10, whatever. 44 times 11 is 1034. In the same notation, in the same base n. Right. Obviously n is not 10. If it was 10 in base 10 system, if it is base 10 decimal system, then 44 into 11 should be 484. But this is not. So then what is this 3111 in the same base notation when converted to base 10? Base 10 is a regular what we generally use. Right. We earlier discussed also base n notation means, for example, if we take some 5 letter or 5 digit number, then in base n, what does that mean? A into n power plus b into n cube plus c into n square, right? So then d into n power 1, then e into n power 0, which is 1, right? Generally, what is the numbers that we talk about are all in base 10 notation. That means a into 10 power 4. That is a into 10,000 plus b into 1000 plus c into 100 plus d into 10 plus e. Right, a, b, c, d. That is what we generally use. That is base 10 notation. We have multiple bases. It can be base 2, it can be base 3, base 5, base 10. Hexadecimal is base 16, which computers use. Right. So you can write in any base. We generally use base 10 because base 10 is very easy for us to understand. Right. Computers use base 2 also. That is binary digits, right? 1001, etc. Right. Now, one thing we should notice is when you write some number in some base, right? Earlier also we discussed how to write numbers in a different ways. We discussed one problem. So, for example, let us take this problem. This one, 1982. Earlier also we discussed 1982. If we have to write in base 12, then how do we write? We just go on dividing 1982 by 12. 12, when we divide 1982 with 12, 12 into 165 is 1980. And it will leave a remainder. So 1982 is 12 into 165. We just divide by 12. Then we write 165. Then remainder. How many times it is divided and what is the remainder. Then in the same thing, in the same 165, how many times 12 will go? 13 times it will go, right? 13 12 around 56 and remainder is 9. Again in 13, how many times 12 will go? It will go once. And what is the remainder? 1, right? 13 minus 12, 1. And again in this 1, how many times 12 will go? It will go 0 times, leaving a remainder of 1. Right? So 1, 1, 9, 2. This is the base notation number of the regular number 1982. 1982, if it is in base 10 notation, if you convert to base 12, it will be called 1192. So clearly 1192 is smaller than base 10. Obviously, it will be 1192 is kind of 1 into 12 cube plus 1 into 12 square plus 1 into 12 plus 2, whereas 1192 in base 10 is 1 into 10 cube plus 1 into 10 square plus 1 into 10 plus 1 into 2. That is obviously 9, 11, 92, right? Base 12 notation, obviously this number, when we convert to base 10, it is 1982 because we started with 1992, right? Base, whenever you increase the base, the smaller number, it will represent a higher value, right? 1192 in base 12 is actually equal to 1982 in base 10. Right, if you convert it to even lower, for example, base 2, then it will be even much bigger number, much lengthier number. Right, yes. So clearly, when you say, whenever you are talking about some base 12, we are dividing everything by 12. Right, everything by 12. 1982 by 12, 165 by 12, 13 by 12, and 1 by 12 everywhere. And we are writing the remainder here. Clearly, the remainder cannot be more than 12, cannot be more than 11 also. It can at max go till 11. Right. So, and with the base n notation or base 12 notation is all about reminders. We are writing the reminders. Right. Now, when you are writing reminders, clearly the remainder cannot be greater than 11. So, base n notation, when n is the any base, the base n notation, there is no digit which is greater than n. Right. So, for example, in this 4 digits, there is no digits which is greater than 12. Everything can be less than 12. In fact, we can get 11 also. Right. And when we get 11, how do we represent? That's a tricky question. So, in hexadecimal, what do we do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, then A, B, C, D, E, F. People use that way. Right. When we get bigger numbers, we use A, B, C, D, E. Instead of using 11 directly, we use like this. That's a different discussion. You should not be worried. So, but any base and notation we represent in terms of the reminders when divided by that particular n. Right. But then how do we know this kind of reminder representation is actually will actually give our base n notation. Why? Because, so for example, 1 is 12 into 0 plus 1. 13 is 12 into 1 plus 1. Let us take this 13 representation, that is 12 into 1, and insert it here. So it becomes 12 into 12 plus 1 plus 9. That becomes 12 square plus 12 plus 9. Now this 165 can be represented like this. Let us insert this in this one, in this 165. So then this becomes 12 square into this entire part. 12 square plus 12 plus 9 plus 2. That becomes 12 cube plus 12 square plus 9 into 12 plus 2, which is what we are looking at. 1 into 12 cube plus 1 into 12 square plus 9 into 12 plus 2. That is base and base 12 notation, right? That's how these reminders they actually work. The reminders, when you get these reminders in the base 12 are actually representing this 1982. Right, guys? This is how we write base and notation. Now coming to this problem, we are given 4, 44n and 11n. What is 44n? In some base n, it is 4 into 10 power n plus 4 into 10 power 0. Basically 4n plus 4. Similarly, what is 11n? 11 is 1n plus 1. Right? 1 into 1n plus 1 naught. In, right? N power 1. Here n power 0 is 1. 1 into n power 1 plus 1 into n power 0. Right? N power 0 is 1. This equals 1034 in the same base n. That means 1 into n cube plus 0 into n square plus 3 into n plus 4 into n power 0, which is 4 into 1, 4. Now, if we just expand this, 4n square plus 8n plus 4 equals n cube plus n 0 n square plus 3n plus 4, which is all what is already given. If 0 n square we can remove, n cube plus 3n plus 4. Then this 4 and this 4 we can cancel, we will be left with n cube plus 3n minus 8n minus 5n. This 4n square we can bring it to the right, minus 4n square. So we can take n common also, then this simplifies to n square minus 4n minus 5, which means n square minus 5n plus 4n. You can write it as minus plus 4n. Sorry, right, the n part. So 5n, n square minus 5n plus 4n, so plus n square minus 5n plus n, right? It should be n minus 5, right? So that becomes n minus 5 into n plus 1 equals 0. Clearly, we are not concerned about the negative number here because base n should be a positive number. So this system is actually base 5 system, right? When we know what is the base, we can very easily convert this 311n, right? It is simply 3 into 5 cube plus 1 into 5 square plus 1 into 5 plus 1, right? Any base. When we know n, it becomes very straightforward. Then this becomes 406, 375, 3 into 125, 375 plus 25, 1 5 square, 25 plus 5, 400, 405, 406. Right. This 406, this is in base 10. All numbers that we generally write are in base 10. Don't get confused. Base 10 is actually one of those representations. It is equal to 4 into 100 plus 0 into 10 plus 6 into 1. Right. You can, just for convenience, we write it in base 10 system. There are different ways. You can write it like 400 in text also, right? 406 and 6. This is also one way of representation, right? Or you can use Roman numbers also. That is also one way of representation. Numbers we can represent in multiple forms, right? Multiple forms. Base 10 is one of those representations. Same number 406 means 406 once. If you write like this, like this, like this, someone might decide that they will continue writing like this. But this is not a very wise way or very convenient way. So that's why people or mathematicians generally decided that base 10 is the system that we will use. Right. In some cases, we use base 6 system also, base 60 also, where when we count minutes and hours, each hour has that 60 minutes and each minute has 60 seconds. right? So this is kind of, it is not 1 is to 10, it is 1 is to 60. So this is kind of base 60, right guys? Let us, we'll get to that later when it is not needed. But this is how we convert from base to one base and system to another base. And this is how we identify what is the base and notation of any given number. Right guys? Hope you like this. Thank you.